Okay, so we're down to our last algebra review. Today we're going to talk about equations and inequalities and how we use them to write word problems. When we see equations, we hear words like is, or more than, or less than. So for example, y more than 6 is 7. That tells you y more than 6, 6 plus y is 7 equals 7. Whereas in an inequality, you have more than and less than, but you have the keywords is in front of them. So twice x is less than 4 minus 8. Twice x is less than 4 minus 8. As we look for keywords, these are some very important keywords that you want to keep in the back of your mind. When you hear the word total, we know that that means equals to, okay? So that indicates the equals to symbol. When we see words like per, each, every, what this tells you is that you need to attach it to a variable, probably your x variable. System, we did system of equations in our last one, means two equations. Or inequalities, it just basically means two. And same is equals, when the two things are equal. It's almost like total, okay? But it's a different use of the word equal. Okay. So when we take a look at the parts of an equation, the number with the variable, so let's first take a look at this linear equation. The number with the variable is the 5 here. The number with the variable is the 1.019, right? Because these are attached to your variables. And then over here, since you have 2, we're just going to ignore it. We don't know what it does here. But this is represented by a rate of change, okay? The number that is attached to your variable is a rate of change. Number without the variable, so in this case, the number without the variable is your negative 10. The number without the variable here is a positive 10. And the number without the variable in your last one is a positive 4. And all of these are your y-intercepts. Always, okay? So the number without the variable is always your y-intercept. Okay, when you're ready, let's turn the page and let's take a look at this first problem. Lizzie has 30 coins that total $4.80. All of her coins are dimes, D, and quarters Q. Which system of equations models this situation? So one thing I know is that we have a total of $4.80. So we have to equal $4.80 somehow. Okay? And then she also has a total of 30 coins, so our other equation should equal 30 coins. And I know we have two equations because of this keyword systems. Well, how do I get $4.80? If I take a look at all of these equations, somehow I need to add your dimes and quarters together. Now let's ask ourselves, why are we multiplying them? Well, the dimes are worth 10 cents, so they must be multiplied by 0.10. And the quarters are multiplied by 25 cents. So quarters are 25 cents, multiply that by 25. And then I also have D plus Q is equal to 30. Oh, I made a typo here. So that's actually answer choice C. You need to fill this in. This is 480. D plus Q is 30, and 0.10 times D plus 0.25 times Q equals to $4.80. All right, to solve our systems of equations, let me make this a little bit smaller. So to solve our systems of equations, if you did the last packet, we need opposite coefficients. So what we're going to do, I'm going to multiply the top by -1, and I'm going to multiply the bottom by 0.10 so that I can get opposite coefficients. So I get -0.10 minus 0.25Q equals to -$4.80. And then on the bottom, 0.10D plus 0.10Q equals to 3 times 0.10 is just 3. So if I use my calculator, I add these two together, they cancel out. 0.25, -0.25, and positive 0.10, that gives you -0.15Q equals to -$1.80. Let's divide by negative 0.15 on both sides. Whoops. Divide by negative 0.15. So, I have my calculator, negative $1.80 divided by negative 0.15. 12. I get that there are now 12 quarters. If I want to find out the number of dimes, I'm going to take one of my equations. Let's take this one because there's less decimals. D plus Q is equal to 30. Well, I know I have 12 quarters, so D plus 12 is equal to 30. Minus 12 from both sides. I get that I now have 18 dimes and 12 quarters. All right, let's take a look at the next problem. Each day, a local dog shelter spends an average of $2.40 on food per dog. The manager estimates that the shelter's daily expenses, assuming there is at least one dog in the shelter, using the function E of x equals to 30 plus 2.40x. Which statements regarding the function E of x are correct? Okay, before I even read those answers, I know 30 is my starting value. Okay, because that is my y-intercept. And now the 2.40 must be a rate of change. Because that is attached to your x. So let's take a look. X represents the number of dogs at the shelter per day. Okay, answer choice 1 says X represents the number of dogs at the shelter per day. That has to be true because each dog costs $2.40, so the X must represent the number of dogs per day. If that's the case, X does not represent the number of shelters per day. 30 represents the shelter's total expenses for the day. That's not true because we said 30 is our starting point. 30 represents the shelter's non-food expenses per day. That has to be true because if I don't buy any food, that's how much it costs to just run the shelter. So 1 and 4 are true, so we're looking at answer choice 2. Okay, question 3. Sarah wants to buy a snowboard that has a total cost of $580 including tax. Okay, here's the keyword total. That means I know it has to like equal to 580 or something. She has already saved $135. Already saved, so this must be my initial amount, what I'm starting with. So no variable here. At the end of each week, she is paid $96 for babysitting, and she is going to save 3/4 of that for the snowboard. Write an inequality that can be used to determine the minimum number of weeks Sarah needs to babysit to have enough money to purchase the snowboard. Okay, I know it's an inequality, so I need to use one of these inequality symbols. Total cost of $580, okay, so I know $580, and if she needs $580 to represent that, I want greater than or equal to 500. That's how much money she needs to buy the snowboard. She already has 135, so let's write that in. She already has that much, and how much is she saving every week? Well, every week she gets $96, and she's saving 3/4 of that. 3/4 of 95 is 0.5. Oh, sorry, 96 is equal to 0.75 times 96. And I get that she's going to be saving $72 every week. And that's the key word, every, okay? 72x plus 135 has to be greater than or equal to 580. So let's go ahead, copy this down here, and see if we can solve. 72x plus 135 is greater than or equal to 580. Okay, first let's minus 135 from both sides. I guess 72x is greater than or equal to, let's use our calculator, 580 minus 135, and I get 445. To solve for x, let's divide by 72. X has to be greater than or equal to 72 divided by, whoops, made a mistake, you guys all do, 445 divided by 72, and I get 6.18. So if it has to be greater than or equal to 6.18, the minimum number of weeks, it's a whole number, x has to equal to 7. We cannot have 6 weeks because 6 weeks is not greater than or equal. So for example, 6 is greater than or equal to 6.18. That's not true, which is why we cannot use it. All right, let's turn the page. Ian is borrowing $1,000 from his parents to buy a notebook computer. He plans to pay them back at a rate of $60 per month. Here it is, $60 per. That means that's a over variable. Ken is borrowing $600 from his parents to purchase a snowboard. He plans to pay his parents back at a rate of $20 per month. So that's 20 and that's your per. Write an equation that can be used to determine how many months the boys will owe the same. Same means when they are going to be equal. All right, so let's start with Ian. So Ian starts off with $1,000 and he's paying back $60 per month. So we're going to take away 60x every single time. Ken starts off by owing his parents $600, so $600, and he's going to pay back $20 per month. So minus 20x. Write an equation that can be used to determine how many months the boys will owe the same. So when they're the same, it means I have to make the two equations equal to each other. 1,000 minus 60x equals to 600 minus 20x. Determine algebraically and state in how many months the two boys will owe the same amount. So let's solve our equation that we wrote. 1,000 minus 60x equals to 600 minus 20x. I'm going to start by adding 20x to both sides. And I get 1,000 minus 40x equals to 600. I'm going to take away 1,000 from both sides. And I get negative 40x equals to negative 400. And then last but not least, let's divide by negative 40. So I get x is equal to 10. So in 10 months, they will owe the same amount of money. Ian claims that he will pay his loan off 6 months after he and Ken own the same amount. Determine and state if Ian is correct. Oh wait, sorry, I didn't finish the second one. State and the amount they will owe at this time. So 10 months later, let's use whichever equation you like. I'm going to use Ken's. 600 minus 20 times 10 equals to 600 minus 200. $400. They will have $400 at this time. So Ian claims that he will pay his loan 6 months after he and Ken owe the same amount. So when they owe the same amount, they both owe $400. 6 months later, Ian pays off $60 a month. So 60 times 6. I get that this is 400 minus 360, which is $40. So Ian is incorrect because he will still owe $40. All right, number 5. Two friends went to a restaurant and ordered 1 plain pizza and 2 sodas. Their bill totals $15, and here's that keyword again, and 95 cents. So this first equation, I'm going to do 1 pizza plus 2 sodas is equal to $15.95. Later that day, 5 friends went to the same restaurant. They ordered 3 plain pizzas, so 3 pizzas, plus each person had 1 soda. There were 5 of them, so plus 5s equals to $45.90. Write and solve a system of equations. So system tells me I need 2 equations. I have 2 equations to determine the price of 1 plain pizza and just 1 plain pizza. Okay. So let me move this over. My bad if you can't do that. If I want to solve this, again, I need opposite coefficients. So what I'm going to do is multiply the top by 3, and I'll multiply the bottom by -1. I get 3p plus 6s equals, come on, $15.95 times 3, $47.85. I'll multiply everything on the bottom by -1. -3p minus 5s equals -$45.90. My p's cancel out. I get 1s equals 47.85 minus $45.90. So to have one soda is $1.95. That's not what they're asking us for. They're asking for the price of one plain pizza. I'm going to use our first equation, 1p plus 2s, and instead of s, $1.95 equals $15.95. So one pizza plus 2 times $1.95 is $3.90 equals $15.95. Okay, if I want to solve for the pizza, minus $3.90 on both sides. And I get 1p is equal to $12.05. So one pizza was $12.05. We're almost there. Question 6. Let h of t equals to this equation represent the height of an object above the ground after t seconds. Determine the number of seconds it takes to achieve its maximum height. Justify your answer. Maximum height is at our vertex. And if you remember how to find the vertex, what we want to do is first plug into our equation for line of symmetry. X equals to negative b over 2a. Negative 64 all over 2 times negative 16, which is negative 64 over 32. Negative 32, which is just 2. So at 2 seconds, we will achieve our maximum height. State the time interval in seconds during the height which the height of the object decreases. So if we try to imagine what this really looks like, right? Our object goes up. Over here is 2 seconds. And then it starts decreasing again, and I want to find out when does it hit the floor again. What are the zeros? So we're going to go to y equals, and let's plug this equation in. Negative 16x squared plus 64x plus 80. Let's take a look at our table. Our two zeros are when the y's are equal to 0, and that's at -1. And x equals to, let's see, 5. Well, these represent seconds, so it cannot possibly be -1. So from 2 seconds all the way until 5 seconds, my height of my object is decreasing. So the interval during which the height of the object decreases is from 2 seconds to 5 seconds. And since we need to explain, this is where the ball reaches the maximum height and starts falling until it reaches the ground. Okay, we got one question left. Question 7 says, the population of rabbits in a lab P of x can be modeled by the function right here, where x represents the number of days since the population was first counted. Explain what 20 and 1.14 represent in the context of this problem. So our 20 does not have an x attached to it, and we talked about in the very beginning that that must be the initial amount. 20 is the y-intercept, which is the initial amount of rabbits in the lab, okay? And since this is an exponential equation, we talk about exponential growth and decay. 1.014 is the rate at which the rabbits are growing. Since it is greater than 1, I know it is growing. Determine to the nearest tenth the average rate of change from day 50 to day 100. So at day 50, let's plug it in. I get 20 times 1.014 to the 50th power. Let's quit this. 20 times 1.014 to the 50th power. and I get 40.08. All right, day 100. 20 times 1.014 to 100 equals, so 20 times 1.014 to the 100th power, 80.32. To find average rate of change, if you remember, that is y2 minus y1 over x2 minus x1. So I actually have my 2 points. My 2 points are 50, 40.08, and 100, 80.32. This is x1, y1, x2, y2. So y2 was 80.32 minus y1, 40.08, divided by 100 minus 50. Let's use our calculator. 80.32 minus 40.08. I get 40.24 on top. 100 minus 50 is 50. So let's take this number, let's divide by 50, and I get 0.8048. Our answer says, our problem says round to the nearest tenth. To round to the nearest tenth, I need 1 decimal place. So 0.1 decimal place, I need to decide what to do with the 8. Either keep it the same or round it up. The 0 tells you to stay the same. So, put an 8 there. Okay, you must complete the practice problems that follow. If you do not, you will not get full credit for this take-home test. All right, good luck.